All right, solving rational equations. So when you're solving an equation, I want you to think of this. So if you had something like x minus 3 over 12 equals 5 over 12, you would automatically know that since the denominators match, x minus 3 has to equal 5. And so you could just forget about the denominator and be like, oh, well, x minus 3 equals 5, so x equals 8. Oh, okay, I'm done. Right? And so imagine that's what we're doing. I mean, that's what we're going to basically be following that principle here. If I can get the denominators in these problems to match, then I am basically going to just be getting rid of them and then solving the numerator. So basically I'm getting common denominators. So when I look at these problems here for number 1, I have x and x plus 2. So I need to get my denominators to all be x and x plus 2 together. So I'm going to give this guy an x plus 2, which means I give him an x plus 2. I need to give this guy an x, which means I give him an x. And 9 has nothing. So not only am I giving him an x, I'm giving him an x plus 2. So I give x and x plus 2. So I know it's kind of messy, but then look across there. I basically have all the denominators are the same, and I don't need them anymore because they all match, right? So I can kind of in my mind just get rid of all those things and then just take the numerator and solve that. I have 15 and x plus 2 plus x times 9x minus 7 equals 9x and x plus 2. And that's what we're going to do. Now, one thing to also mention here is we have some things that we cannot allow to happen. So I have a domain issue here. I can never let x be 0 or negative 2. My answer, because if x were negative 2, that would make that denominator 0, and if x were 0, it would make that denominator 0. So I have some restrictions on what I will allow x to be. So if that comes out to be my answers, I will not accept them. And that might happen to some of these problems here. So let's work this out. I get 15x plus 30 plus 9x squared minus 7x equals 9x squared minus 18x. So you might be thinking, oh my gosh, look at this problem. But look what happens. These 9x squareds cancel. My problem just got like a lot easier. So 15x minus 7x, I get 8x plus 30 on this side. And on the right, I have 18x. So let's take away 8x from both sides. I get 10x equals 30. So x equals 3. And that is not one of the restricted values, so I'm going to keep it. So let's do that same problem here. Oh, good. We don't have to do that one. So let's go ahead and before we do number 2, let's go and look at, and 3, let's look at number 5. So same idea here. You need to decide what a common denominator would be. So if I look at all these denominators here, it looks like everybody wants an x, and 2 and 3, I'm going to have to grow them to be 6. So 6x is going to be the common denominator I'm going for. So I'm going to have to give him an x, give this guy a 6, give this guy a 2x, and give this guy a 3. Then all the denominators would be 6x. So let's see what we got. We have 5 times 3 is 15 minus 4x equals 6 plus 5x. Okay, and one thing to note, x can never be 0 because I can't have that be 0. Or here. Okay, so I'm going to take away 6 from both sides and get 9. Add 4x to the right and get 9x. So I end up getting x equals 1, which is not 0. So I'm all set. Now, in these problems up above, number 2 and number 3, we could do the whole, what's it called, the common denominator bit. But remember, you can also, when you have a fraction equal to a fraction, you can cross multiply. That's a little bit easier to do here, or to think of. So I'm going to multiply 3n by n minus 1 is going to be equal to 2 times n plus 4. And also, in my domain, n can never be negative 4 or 1. All right, so let's see. We got 3n squared minus 3n equals 2n plus 8. Oops, not x. So I have a 3n squared on the left. I'm going to be stuck factoring here, so I need to bring everything to the left. So take away 2n here. So I have 3n squared minus 5n, and then bring that 8 over, minus 8. All right, let's factor this up. All right, so if I use, 4 and 2, let me just try a few. So, oh no, 8 and 1, because that'll be 3n, and 8n can get my 5n. So 8 here and 1 there. So let's see, minus 8, positive 1. Yes, that works. All right, so then my solutions are going to be 8/3 and -1. Close call, so it wasn't positive 1, it was -1, so these are both fine. Now, if this had said -1 here, then I would have written this down, but then I would have kind of crossed off this answer, and I would have only answered this. Okay, so if you have a solution that it's called an extraneous solution. It's like when it's not allowed, if it actually comes up in your answer, this one didn't, but if it comes up, you kind of cross it off and say you don't accept it. All right, so let's look over here. So my domain is that x can't be 0, because 4 times 0 is 0, and 0 squared is 0, so let's cross multiply. All right, so we get this, 3x squared equals this, so 4x times 5 plus x. It doesn't matter which side you put where. So I have 3x squared equals 20x plus 4x squared. So I'm going to keep my x squareds positive, so I'm going to take away 3x squared here. So it's going to give me 1x squared plus 20x. And so when I go to factor this, I get x and x plus 20. So I get x equals 0 and -20. But look here, x can't be 0. So I can't have that. So x equals -20. That's my only solution that I will accept. All right, and that's how you solve rational equations. Bye-bye.